When Soviet scientists drilled deeper into the Earth than anyone in human history, they expected to confirm decades of geological theories. Instead, the Kola Superdeep Borehole revealed a series of discoveries that challenged some of their most basic assumptions about the planet beneath our feet. Located on Russia's Kola Peninsula near the Norwegian border, the project began in 1970 as part of an ambitious scientific effort to explore Earth's crust. The goal was simple but extraordinary: drill as deep as possible and learn what lay beneath the surface. Engineers hoped to reach 15,000 meters, a depth never before attempted. At the time, the Soviet Union viewed the project as both a scientific mission and a demonstration of technological achievement during the Cold War. Massive drilling rigs were installed, teams of geologists and engineers worked around the clock, and for years the operation progressed steadily. The drill passed through layer after layer of ancient rock while scientists carefully analyzed the core samples brought to the surface. Initially, everything appeared to match accepted geological models. Temperatures, rock compositions, and structural formations seemed to confirm what researchers believed about Earth's crust. But as the borehole pushed deeper, unexpected anomalies began to appear. One of the earliest surprises involved a geological boundary known as the Conrad discontinuity. For decades, scientists had interpreted seismic data to indicate that granite should transition into basalt at a certain depth. Yet when the drill passed through the expected boundary, no basalt appeared. Instead, there was simply more granite. The discovery forced researchers to confront the possibility that their interpretation of seismic signals was incomplete or even fundamentally wrong. A geological layer that had existed in textbooks for generations suddenly seemed far less certain. As drilling continued, additional mysteries emerged. Core samples recovered from several kilometers below the surface contained evidence of water trapped within microscopic fractures in the rock. According to prevailing theories, such depths should have been too hot and too heavily compressed for liquid water to persist. Yet the evidence was undeniable. Scientists concluded that water from the surface had slowly migrated downward over immense spans of time, becoming trapped under extreme pressure. This finding suggested that Earth's crust was far more interconnected and permeable than previously believed. Even more surprising were the concentrations of hydrogen gas detected in drilling fluids returning from the depths. Researchers observed the fluids bubbling as they reached the surface, indicating significant amounts of dissolved hydrogen. No existing model adequately explained why such concentrations should exist so deep underground. Some scientists proposed that chemical reactions within the rocks generated the gas, while others believed it had remained trapped for billions of years before being released by drilling. Regardless of the explanation, the discovery pointed to geological processes that were poorly understood. Then came one of the most controversial findings associated with the project. Deep within ancient rock formations, scientists identified microscopic fossilized remains of marine organisms. These tiny fossils appeared to be billions of years old and were preserved under conditions many researchers considered too extreme for organic structures to survive. Their existence challenged assumptions about the limits of fossil preservation and raised important questions about the resilience of organic material over geological timescales. Although the fossils themselves were genuine scientific discoveries, later sensational stories exaggerated their significance, transforming legitimate findings into claims of hidden mysteries and suppressed truths. Yet perhaps the greatest challenge came from temperature. Scientists had carefully predicted how hot the rocks would become as the drill descended deeper into Earth's crust. Their calculations suggested temperatures around 100 degrees Celsius near the project's target depth. Reality proved very different. As the borehole approached its deepest levels, temperatures exceeded 180 degrees Celsius, far hotter than expected. The intense heat altered the physical behavior of the surrounding rock. Instead of remaining rigid and brittle, the rock began to deform plastically under pressure. Drilling equipment struggled to function under such conditions. Drill bits wore out rapidly, instruments failed, and sections of drill pipe became trapped. At one point, thousands of meters of drill string broke off and were lost deep underground, forcing engineers to begin a new branch from a shallower depth. Despite repeated efforts to overcome these challenges, the extreme environment ultimately imposed limits that technology of the era could not defeat. By 1989, the borehole had reached a depth of 12,262 meters, establishing a world record that still stands today as the deepest artificial point ever created by humanity. Yet despite this achievement, the original goal remained out of reach. The deeper scientists drilled, the more difficult conditions became. Rock temperatures continued to rise, equipment failures increased, and progress slowed dramatically. Then history intervened. The collapse of the Soviet Union brought severe financial difficulties, and funding for large scientific projects rapidly disappeared. By the early 1990s, support for the Kola project had dwindled. Efforts to continue drilling were eventually abandoned, and the site was closed. What remained was a narrow hole only 9 inches wide at the surface but extending more than 12 kilometers into Earth's crust. Over time, legends began to surround the project. Stories circulated claiming that scientists had heard mysterious sounds from deep underground or discovered evidence of supernatural phenomena. None of these tales were supported by scientific evidence. The real discoveries were remarkable enough on their own. The absence of the expected basalt layer, the presence of deep water, the unexpected hydrogen gas, the ancient microfossils, and the extreme temperatures all demonstrated that Earth's interior was more complex than researchers had imagined. Rather than uncovering evidence of hidden civilizations or supernatural forces, the borehole revealed something equally important: the limitations of scientific models. Many accepted theories had been based on indirect measurements such as seismic waves and laboratory simulations. The Kola project provided direct evidence from depths never before reached, allowing scientists to compare theory with reality. In many cases, reality proved more complicated. These findings did not overturn geology, but they refined it. They showed that Earth's crust contains processes and structures that cannot always be predicted from surface observations alone. In the decades since the project ended, geologists around the world have continued to study samples recovered from the borehole. The data collected there has influenced research into crustal structure, geothermal energy, deep subsurface water systems, and the behavior of rocks under extreme conditions. Other deep drilling projects in Europe and elsewhere have encountered similar surprises, confirming that many of Kola's discoveries were not isolated anomalies but part of a broader pattern of geological complexity. Today, the site itself is largely abandoned. Rusting equipment and weathered buildings stand as reminders of one of the most ambitious scientific projects ever attempted. A metal cap seals the entrance to the borehole, hiding the deepest point humanity has ever reached beneath the surface of the Earth. Yet the legacy of Kola is not the record depth. Its true significance lies in what it taught scientists about uncertainty. Every unexpected result challenged assumptions and forced researchers to reconsider what they thought they knew. The project demonstrated that direct exploration remains one of the most powerful tools in science. Models, theories, and simulations are valuable, but there is no substitute for actual observation. The deeper scientists looked, the more they discovered that nature often refuses to behave exactly as expected. The Kola Superdeep Borehole remains a symbol of both human ambition and scientific humility. It showed that even after centuries of study, our planet still holds secrets. Beneath the continents lies a world of immense pressure, extraordinary temperatures, hidden fluids, ancient fossils, and geological processes that continue to surprise researchers. One day new technologies may allow humanity to drill deeper still, perhaps even reaching the mantle itself. When that happens, scientists will almost certainly encounter discoveries that challenge today's assumptions just as Kola challenged those of the 20th century. The greatest lesson from the deepest hole ever drilled is not that scientists uncovered something terrifying or tried to hide a secret. It is that every journey into the unknown reveals how much remains to be learned. Far below the surface, the Earth still guards mysteries waiting for future generations to uncover.